Hello, everyone. My name is Andy Hopper, and I'm a Senior Solutions Architect at Amazon Web Services. It can be awfully useful to have a way to automatically install an application on an EC2 instance. A good example would be rolling out a line of business application across a fleet of machines, and you don't want to have to wait for a human being to connect to each machine and install your software. In this video, we're going to explore how you can use a feature of AWS Systems Manager called Automation Documents. For those of you who aren't familiar with Systems Manager, it's an AWS service that allows you to group and manage resources such as Simple Storage Service, or S3, buckets, Relational Database Service, or RDS, servers, or Elastic Compute Cloud, or EC2, instances. In addition, you can install the Systems Manager agent on your own on-premises machines to provide a consistent management experience for both your AWS and non-AWS resources. As I mentioned earlier, Systems Manager has a feature called Automation Documents, and what this is a way for you to create a sequence of steps that will be executed to perform management operations. These steps can be executing AWS commands to perform actions like creating or modifying resources, executing scripts to evaluate complex logic or customize the document flow, or even run shell commands on instances. In this video, we'll be taking advantage of some of these features to install our application. For the purposes of this video, we're going to focus on a Windows use case. However, the same set of tasks can be performed on a Linux box. You'll just be using a different syntax for any shell commands you run. So, let's get started. What I have open here in Visual Studio is an ASP.NET Core MVC web application. Now, I'd like to point out that while this particular application is using the .NET Core runtime, everything I'll be describing in this video applies to .NET Framework applications as well. You're just going to be using a different runtime for your application. By the way, the source for this application is publicly available in GitHub, so if you want to peek at the code for this, as well as some other videos I'll be recording on deploying .NET applications, you can download it and try it out in your own environment. Okay, back to our application. I'd like this application to be able to launch automatically on boot and stay running. This is an ideal use case for a Windows service, so I've added the NuGet package that supports running a .NET Core application as a Windows service. So I've got my application, I've got it set up to run on boot, so now I just need to figure out how I'm going to get this to automatically install on my instances. Before we start, there's a few things we need to have in place. In order for Systems Manager to be able to execute automations on an instance, it needs to be able to interact with the Systems Manager agent running on the instance. If you're using an AWS supplied image, this agent will already be installed, but it still needs permissions to call Systems Manager APIs for the agent to interact with the Systems Manager service. To do this, you need to create something called an instance profile and attach a policy to this profile that grants these permissions. To assist with this, AWS provides something called a managed policy called Amazon SSM Managed Instance Core. Managed policies are Identity and Access Management, or IAM, policies that AWS has already defined and will maintain in case any permissions need to change in the future. Anyway, this Amazon SSM Managed Instance Core policy includes the permissions needed to allow the agent on the instance to communicate with Systems Manager, and likewise for Systems Manager to perform actions using the agent. The last thing to be aware of is that the agent needs to be able to reach the Systems Manager service endpoints, so you'll either need to set up your VPC with an internet gateway and possibly NAT gateways to provide internet access to private subnets, or for VPCs that will not have internet access, you'll want to set up something called a VPC endpoint for Systems Manager. Let's get everything set up. First, let's go ahead and set things up so our agents will have permission to interact with Systems Manager. To do this, we're going to go to the Identity and Access Management console. We'll navigate to Roles, and we'll create a role. We'll indicate that this is going to be for an AWS service, and namely EC2 instances. And next, we'll configure the permissions that are going to be attached to this role. So we'll add Amazon SSM Managed Instance Core. And we'll skip the tags and just go to Review, and we'll give this a name. We'll call it Automation Deployment Demo. Okay, great. We have our role. Now let's launch our EC2 instance. To do this, we'll go to Services. We'll navigate to EC2. And then we'll click on the Launch Instance button. Now, as I mentioned before, we're going to be working with Windows. So I will search for Windows AMIs. I will select Windows Server 2019 Base, and I'll stick with the default of a T2 Micro for the instance size. Now, for the purposes of this video, we're going to go ahead and use my default VPC, which gives me access to the public internet. Next, what I'll do is for the IAM role, I'll choose that automation deployment demo role that we created for the EC2 profile. I'll skip past the storage and the tags. And next, I'll configure the security group. Now, in this case, since I'm going to have SSM manage this instance, I'm not going to bother configuring RDP access for it. Instead, what I'll do is I'll select HTTP because I want to allow access to my web application, and I'll allow it from the public internet. And I'll give this a name like Automation Demo SG. Next, we review everything that we've chosen, and we'll go ahead and launch. And again, because I'm going to let SSM manage this, I don't intend to ever log into this box. So I'm going to go ahead and say proceed without a key pair, and I'll check the checkbox saying I acknowledge that I won't be able to directly log into the machine. All right, so my instance is now launching. Let's move on to SSM to create our automation document. So before we write our automation document, let's plan ahead and consider the steps that I'll want my automation document to perform. First, I'd like for it to download and install the ASP.NET Core runtime if it's not already on the box. Then I'd like to download my application. I'd like to configure the application to run as a service. And finally, I'll ensure that my application is accessible on the standard HTTP port of 80. Now that we know what we want to do, it's time to create our automation document. So let's navigate to Systems Manager. And because I want to create an automation document, I'll scroll down to the Document section, and I'll click on Create Automation. It's going to prompt me for a name for my automation document. I'll call it Install App Server. And next you'll notice that you by default are placed in what's called the Document Builder. This is a graphical user interface that provides a human-friendly experience for defining your automation document and the steps it needs. If you like, you can move over to the Editor tab, and it gives you a document editor that you can write either JSON or YAML to define your document and its steps. However, for this video, I'm going to go ahead and stick with the Builder experience. And I will modify the document attributes with some markdown that describes my document. Now, we'll want this document to work on a set of EC2 instances, so what we'll do is we'll add an input parameter, and we'll call it instance ID. And since this can be one or many instance IDs, we'll make it a string list. And because this document is not going to be able to function without getting this instance ID, we'll go ahead and make it a required parameter. Now it's time to define our steps. Remember that I want to install the .NET Core runtime if it's not already present on the box. However, I'd like to skip the installation if it's already on the box. So what I'm going to do is run a script on the machine to detect what versions of the runtime are present. So let's name this step get ASP.NET runtime. And for the action, what I'm going to do is run a script on the box. Now, I actually prefer PowerShell, so I'm going to choose run a command on a managed instance. And next, it's going to ask me what document name I'd like to run. Now, I happen to prefer PowerShell, so I'm going to choose the AWS run PowerShell script document. Now, what this wants is a list of the instance IDs that we're going to use this document on. And so what I'll do is I'll supply the instance ID variable that we defined in our document. And you'll notice I'm using a special syntax to evaluate this variable. It looks like mustache syntax or double curly braces on either side of it. And what this is doing is telling SSM to evaluate the value of this variable to supply this value. Now, the other thing this document's going to want is the set of commands that I'm going to send it. So what we'll do is we'll choose parameters, and then what we're going to do is paste the script that we're actually going to run on the machine. I'm going to go ahead and expand this up a little bit so we can read the whole thing, and let's actually take a look at what the script is doing. So first, I'm telling it the name of the .NET executable that I'm looking for, and again, remember, we're looking for .NET Core, so it's .NET.exe. Next, If it actually finds the command on the path, then it will actually execute the list runtimes command to see what runtimes are present on the machine. If it doesn't find anything, it'll set it as an empty set of responses. Finally, what we'll do is we'll run a quick grep on this string to find the value of the ASP.NET Core runtime version. And then finally, we'll return the value of that variable to the output of this command. Now it's time to see if I need to install the ASP.NET Runtime. Let's add a step, and we'll call it dependency check. And this time, instead of running it on the instance, we're actually going to run it within the document itself. For the inputs, it's going to ask what language I want to use. And again, I prefer PowerShell, so I'll choose PowerShell Core 6.0. And next, it's going to want the script we'll actually execute. So let's take a look at what the contents of this script are. So first, I'm going to safely assume that no matter what, I'll install the runtime. You can do that even after the runtime's been installed. That just means the document will take a little bit longer to execute. Next, I'm setting a variable to the value of the .NET runtime I'd like to have installed on the machine. And then next, it's going to take an input that tells it what the current ASP.NET runtime is. And we'll set this up in just a moment. Finally, we'll do a quick comparison to see whether or not the installed runtime matches the actual version of the runtime matches our desired version. And then finally, what we'll do is we'll return a payload that has a property on it called install runtime, which is to value whether or not the version that's on the box is greater than or equal to the version that we desired. Now, let's give our script the data it needs. To do this, we'll add an additional input. And in this case, we'll supply value to input payload. And if you see up here, what we're looking for is a value on input payload that's named ASP.NET Runtime Version. So we'll go ahead and paste that in here for the input value. And again, you'll see that syntax. And what we're doing here is we're evaluating the output of our previous get ASP.NET Runtime step. Next, let's define an output for this step that we'll use to determine whether the runtime needs to be installed. As you see up here, our script has a return value that defines a property named install runtime. We'll also use that name for our output. So we'll call it install runtime. The selector is going to come out of that output payload. So if you recall, we're returning a structure that has the install runtime property on it. So we'll have it do the $payload.install runtime. And then last, we'll choose what the type of this data is. Now, this is going to be a true-false value, so I'm going to go ahead and choose Boolean here. So now let's use a neat feature of automation documents. Documents support the ability to conditionally execute steps by jumping to a specified step. First, let's add our step. We'll give it a name. We'll call it choose next step. We'll choose run conditional automation steps. And then we'll paste our choices. And again, I'll expand this a little bit so we can take a look at what's going on. And you'll see what's going on here is our next step will be set to install application based on the value of our previous dependency check steps output of install runtime. If the install runtime value is false, then we're going to go straight to install application. Now, if we don't detect the runtime, we'll want to install it. So let's make that the default next step. And we'll have to go ahead and provide a name for this. So what we'll do is we'll call it install ASP.NET Runtime. And this will be a new step we define that actually runs a script that installs the .NET Runtime on the machine. So let's define the step to install the runtime if it's needed. So we'll add a new step. And to make sure it matches our choice step above, we'll name it install ASP.NET Runtime. And again, this is going to be running a command on a managed instance. And again, because I prefer PowerShell, we'll do AWS run PowerShell script. And again, it wants the instance IDs. And then we'll give it the commands as a parameters input. So let's take a look at the script that I have here. All right, so what this does is first ensures that there's a directory for the .NET runtime to be downloaded. Then I'm actually invoking a web request that will call a URL to download the latest version of the runtime. Now, at the time of recording of this script, the most recent runtime was 3.1.6. If you decide that you'd like to build this document yourself, there may be a more recent version on the Microsoft website for download. Once I have that in place, then I will install the ASP.NET Runtime on the machine. And all I'm doing here is I'm using the start process commandlet, and I'm just telling it to wait until the installation has completed. And then I'm just giving it a couple of parameters to tell the runtime to install, to do it without any user interface, because after all, we're not connected to the machine's desktop. And I also want to tell it to not restart the machine if it doesn't need to. Now, since this is just executing a set of commands, we don't need to configure any outputs. Okay, so now we've defined our step to install the runtime if it wasn't already installed. Now it's time to define our last step, which is going to be the one that installs the application. We'll name it install application, again, to match the choice block we had above. And again, this is going to be running a command on a managed instance. Again, the inputs here are going to be the AWS run PowerShell script, and the instance IDs, again, will be the instance ID variable, and then we'll paste our script that actually performs the installation as the parameters. So we'll go ahead and paste the PowerShell script that does the installation, and let's dissect what we're actually doing here. So first, I'm going to check to see if the service was already installed, which means I've run the script before on an instance. I'll go ahead and stop the service so I can update the code. Next, if I didn't already have a directory to host my application server code, I'll create it, and if one already exists, I'll just go ahead and empty it out because I'm going to be putting new code in there. Next, I'll download the latest revision. And in my case, what I've done is I've zipped up the output of my build, and I've uploaded it to an S3 bucket that I control. And then what I will do is expand the zip file. And once I've expanded the zip file, I will register a service if I didn't detect that a service had already been set up on the machine. Then I'll start the service, and finally, I'll open up port 80 so I can allow the outside world to invoke HTTP port 80 on the machine. And again, because this is just executing commands on the box, it's not going to have any output variables. Okay, so we've defined our document. Now let's go ahead and create our automation. Now let's run our new document. We'll click on Automation, and we'll do Execute Automation. We'll choose the Owned by Me tab, and we'll see our new Install App Server. We'll go ahead and click on that. And now it's going to ask for some additional parameters, such as the instance ID. Now, I happen to capture that instance ID when we created our instance earlier, so I'll go ahead and paste that into the instance ID box, and I'll click Execute. Now, rather than make you sit and wait for the entire document to finish executing, I'm going to use the magic of video editing to fast forward in time. I'll see you on the other side. All right, so our application has successfully installed on the machine. So let's actually go and verify for ourselves that the web application is up and running on the box. So let's navigate to EC2, and we'll look at our running instances. We'll paste our instance ID into the field here. And we've got the IPv4 public IP. We'll copy that to the clipboard, and we'll navigate to that page. And what-ho, we have our ASP.NET application up and running on the machine without any involvement from a human being whatsoever. Now, the last thing I just wanted to show was, let's say we have already installed a version of the application, which means we've got the ASP.NET runtime already installed on the machine. Let's verify that our conditional execution step actually works the way we expect it to. We'll copy this instance ID one more time. We'll go back to automation. We will execute an automation. We'll choose Owned by Me again. We'll paste our instance ID, back into the window here, and we'll click on Execute. And again, I'm going to go ahead and skip forward in time just to save you some time watching this video. And now our document has finished execution, but you'll notice that it skipped the install ASP.NET runtime. What this means is when it did the check of the ASP.NET runtime versions and it performed the dependency check, it determined that the ASP.NET runtime was already present. And so when it got to the choose next step block, it jumped to the install application step rather than going through the install ASP.NET runtime again. So again, the very powerful way for you to have conditional execution of steps inside your document. So let's go over what we covered today. First, automation documents are a fantastic way for you to automatically execute either AWS commands or even scripts on your EC2 instances. You can write these automation documents manually in the console using the document builder, or you can use the JSON or YAML syntax in the editor, or you can deploy them into your AWS account using CloudFormation templates. And as we saw here in today's video, the automation documents actually have a wide range of capabilities, not only just executing scripts on EC2 instances, but you also have the ability to execute scripts so you can have custom logic inside your documents. And you can also do things like have branching inside the document where you can skip steps or jump to other steps based on the execution results from either commands run on your EC2 instances or from the execution of scripts inside the automation documents. Thank you very much for watching the video. Again, here is the GitHub repo that's got the deployment samples code if you want to go ahead and deploy this into your own account. Thanks for watching, and we can't wait to see what you build on AWS.